how do you sketch a quadratic function that looks like this? And it might seem silly, let's draw a picture of this function. But it's really useful because then you can get a visual, graphical idea on what this function looks like. It says quadratic function, and this really is a quadratic function. I'll leave that to you to prove. And to sketch it, we first want to find the Y-intercept and the X-intercepts. I guess you can do that in either order. First, let's try finding the Y-intercept. The Y-intercept is where it crosses this line, and at every point on this line, x equals 0. So it's kind of backwards, right? That a Y-intercept has an x value of 0. The x-coordinate is 0. So let's find the point of this quadratic, this parabola, that touches or cuts through this line where x is 0. We have this hint. We know x is 0 because it is a y-intercept. So let's substitute that into our equation. We will write the equation all over again, but wherever we see an x, we will replace it, substitute it with 0. So this will say y equals 0 take 2, bracket 0 plus 5. Good. And now let's just see what happens. The next line, therefore, I'll copy down the y and the equals. I've got two things in brackets next to each other, so there is an invisible times sign here. We don't normally write it, but there is an invisible times sign. And this first number is 0 take 2. You know, doing our BEDMAS, our brackets first. 0 take 2 is negative 2, the invisible times sign, and then 0 plus 5 is 5. So in other words, this thing in brackets is negative 2, this thing in brackets is 5. Let's see what happens next. Therefore, y, copy down the equals, negative times positive is negative, 2 times 5 is 10. Y is negative 10. In other words, if x is 0, then y is negative 10. So 0, negative 10 is a point on this quadratic. So x is 0 and y is negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's label that. That is the y-intercept. I mean, there are lots of quadratics that go through that though, so we need a bit more information. Let's try finding the x-intercepts. The y-intercepts are when x equals 0, so the x-intercepts are when y equals 0. The x-intercepts are on this line, and every point on this line has a y value of 0. So we know the x-intercepts have a y value of 0. So let's substitute. We'll copy down our equation and substitute. We'll replace, every time we see a y, we'll replace it with 0. So instead of y, I will write 0. I'll copy down the equals, and I don't know what x is, so I will just copy down the rest of the equation as is. Now, let's see what happens. Can we solve this? Can we figure out the value or values of x that make this true? Yes, of course we can. We've got two things multiplied together. This thing times this thing equals 0. So by our good friend, the null factor law, we know either x minus 2 equals 0 or x plus 5 equals 0. Cool. So one of these two things has to be true if y is 0. We can solve this equation. One way to solve it is this negative 2 term moves to the other side and becomes positive 2. 0 plus 2 is 2. So this equation has a solution of x equals 2. I chose to put the plus sign in, but you don't have to. Or the solution to this one, plus 5 moves to the other side, becomes negative 5. 0 take 5 is negative 5. So that side, x equals negative 5. So there are actually two x-intercepts. There are 2 points on this line where y equals 0. And one point is x is 2, and one is x is negative 5. Those are the x-intercepts. Let's plot those. X equals positive 2 is right here. And x equals negative 5, 1, 2, 3, 4, 5 is right here. So those are the x-intercepts. And now we can sketch the graph. We can use a trick that I've seen before where if we see these two x-intercepts and look at the point right in the middle, do you notice that this is 1, 2, 3.5 units? And on this side, 1, 2, 3.5 units. So you can double check that that's exactly in the middle. And then imagine a vertical line there. Or you can draw the vertical line as a dotted line with a ruler, obviously. And now we know the parabola is symmetric on this line. And the turning point is on the line. So you can imagine a parabola, which is like a big smile. Oh dear, this is really hard to do on a touch screen. But the parabola has its turning point right on this dotted line, this axis of symmetry, as it is called, and it's a mirror image around that. So that is how you can, given just this tiny piece of information, that this function has this equation, you can get a visual idea for what this graph actually looks like. And that unlocks all sorts of future skills, like solving quadratics and stuff like that. All right, so I hope this has been helpful. Let me know if you have any questions, and good luck. Bye, everyone.